Hello and welcome, chemists, to our lesson on limiting reactants. I advise you to take a look at the lesson posted on Google Classroom in addition to this video, but this should help you solve the problems with them a lot as well. I'm going to pull up this photo from the lesson to begin because I think it's a good, quick and simple analogy for what exactly we're talking about. So this hot dog in the bun here, think of it as a reactant in a chemical reaction, the two things that go in. And think of this is like the product, the hot dog in the bun. You may have 5 hot dogs, but if you only have 4 buns, that means you can only make 4 complete hot dogs. Same thing for chemistry. You may have like a ton of one reactant, like you could have like 9 million pounds of like sodium, but if you only have like a couple of chlorine molecules, you can only make a couple sodium chlorides. Like you only can make as much as your limiting reactant. Think about it as like the baking cake example. If you have like 90 million bags of flour, but you only have 2 cups of sugar, you can't make like a million cakes, right? So just based on what you have less of, what you can make less product of, that's what we're going to have to go with because you can only make as much as your limiting reactant lets you. So here's an example that'll help put it into more understandable terms, I think. I'm just going to remind you before we get going, though, these 5 steps. Make sure the equation's balanced. Every stoic problem always make sure it's balanced, otherwise everything will be off, and that's just unfortunate. Then we have to figure out what we know, add conversion factors, cancel units on the bottom, put the units we need on the top, multiply top, divide bottom. All those steps will fall into place. And if you're still iffy on these, please just go back to the last couple stoic videos and keep practicing on that. Um, because this is kind of an extension of like those basic stoic skills. But if you still want work on that, that's completely cool. But go back to those videos and those will help you get a good understanding heading into this limiting reactant scenario. So I'm going to give you a second right now. Take a look at that reaction. We have sodium carbonate reacting with calcium hydroxide to produce sodium hydroxide and calcium carbonate. And I want you to check if it's balanced. Before we even get to the question, just make sure this is balanced. I'll give you a second to pause it here. And it wasn't originally balanced, but this is the balanced reaction. 2 sodium, 1 carbonate, 1 calcium, 2 hydroxide, 2 hydroxide. So now we're good to read our question and get to understanding how we could lay this out. So without further ado, how many grams of sodium hydroxide can be produced when 112 grams of sodium carbonate is reacted with 45 grams of calcium hydroxide? Right off the bat, the thing that you'll notice is different here is it's giving us data on 2 different reactants, but we can't have 2 different answers. So how are we going to go about that? We are going to do a case 1 and a case 2 scenario here, and then see how much of the sodium hydroxide we can produce, and whatever makes less will be our final answer. But these questions do require you to do kind of 2 questions in one. It's kind of like 2 of the earlier stoic problems like put beside each other, then you have to compare the values. So I'll give you a second here. Try to map out case 1 and case 2, what you'd be starting with and where you'd want to end up. Then I'll pick back up here in a couple seconds. So 5, 4, 3, 2, if you paused it, 1, cool. So case 1, that's with sodium carbonate. And since we're given 112 grams of sodium carbonate, we will have to use conversion factors, so we'll get to that in a sec. And we want to find a mass of sodium hydroxide. These are the molar masses you'll need to get through this. I'll just like give them to you now because our focus here is more on limiting reactants. So that's case 1. If you figured out that case, awesome. If you didn't, just keep following along. Try to sort out what the second case could be, considering this is the first case. You can take a second if you like. Okay, so case 2, calcium hydroxide. We're given 45 grams of calcium hydroxide. We want to find a mass of sodium hydroxide as well. And those are irrelevant molar masses. So these are the 2 scenarios, but only one of them will actually happen. And whichever one happens is what we call the limiting reactant. Whatever one makes less sodium hydroxide will be the answer we go with because you can only make as much as the lesser amount. And so after that, you're going to run out of one of these two things. So here are two ways to map it out. You'll notice I've highlighted the step here. That's because we're going to pause just after we get moles of sodium hydroxide. Then we're going to kind of just go on whatever path makes less. So whatever one has less moles is the one we'll use to get our final answer because that's the limiting reactant. So I'd invite you to take a second here and try to calculate up to the moles of sodium hydroxide. Then, based on the numbers you get out, try to conclude on which one is the limiting reactant. Take a second here, chemists. I'll give you 3, 2, 1 to pause, and we are back. All right, so here's our first scenario. We start with our 112 grams of sodium carbonate. Then we have to find moles of sodium carbonate. So we're going to cancel out grams. We'll be left with moles. This is just using the molar mass from over here. Then we have to convert to moles of sodium hydroxide using our coefficients from the balanced reaction. We'll cancel out moles of sodium carbonate, and we get left with a potential 2.11 moles of sodium hydroxide. Before we turn this into a mass, just to save us some work, let's compare with calcium hydroxide and see which one makes less. So here, similar steps, we're going to take the 45 grams, divide it by the molar mass to cancel out the mass of calcium hydroxide. Ooh, that's supposed to say calcium hydroxide up here. Just pretend it does. So then we're going to take moles of calcium hydroxide and cross it out. It's supposed to say that over here, same thing. But then we're going to be left with moles of sodium hydroxide, and in this case, we can only make 1.21 moles of sodium hydroxide. So I want you to look at those two values and compare them. Out of these two, which one do you think is the limiting reactant? Try to conclude, and then with whatever value you think is limiting, get the final answer, get a number, and then hold tight, and we'll be back in a few seconds so you can check your work. So 5, 4, 3, 2, 1. All right, so this one will not happen because 2.11 is bigger than 1.21. You can only make as much as your lesser amount. That's what a limiting reactant means. So we're not going to do this step, but we are going to do this step. We're going to take this mole value and find a mass of sodium hydroxide, and that'll be our final answer. So we can say that calcium hydroxide is the limiting reactant. So now to get our final answer, it's asking us for how many grams of sodium hydroxide. We're just going to take that mole value from the limiting reactant and say 1.21 moles sodium hydroxide times 40 grams per mole is 48.4 grams of sodium hydroxide. Then when we report our final answer, we're just going to say how much can be produced and what the limiting reactant is. This is your final answer down here. 48.4 grams of sodium hydroxide can be produced, and calcium hydroxide is limiting. All right, chemists. So that's the classic limiting reactant problem. If you can do this solid, you are golden. If you can't, don't worry. Watch this video again, watch the YouTube examples I posted, and try the practice, and it'll click eventually. But if you do have any questions, or you want to request another example or something, feel free to email me right here at mrbsciencemb@gmail.com. I wish you the best of luck, and if I don't talk to you again until after spring break, have a lovely spring break, and make sure you practice as much as you need. Have a great day, chemists, and yeah, see you later.